chapter is the concept of moles. So what is a mole? Just how in usually when we are talking about number of eggs or bananas, we count, instead of saying that we have 12 bananas or 12 eggs, we usually say we have a dozen eggs. When we talk about sheets of paper, we usually say 500 sheets is equal to 1 ream of paper. Similarly, when you see a can of Coke or soda, we basically usually say that 24 cans is 1 case. That basically helps us to reduce the number or quantities of the atom that we are working with, right? This is just a term that has been used to replace the actual number of items. A similar quantity that is used in chemistry is called mole. 1 mole in chemistry is equal to 6.02 times 10 raised to power 23, which means if I say we have 1 mole of carbon, that means I'm saying 1 mole of carbon is 6.02 times 10 raised to power 23 atoms of carbon. So 1 mole of anything in chemistry is equal to 6.02 times 10 raised to power 23 particles. That can be atoms or it can be molecules, whatever we are talking about. This number right here is called Avogadro's number. 1 mole of any chemical compound consists of 6.02 times 10 raised to power 23 particles, atoms, or molecules. You need to memorize this number. Just make sure 1 mole is just a unit defined as Avogadro's number. So basically you could say 1 mole is these many particles. Particles can be in terms of atoms, molecules, or ions, and this can be used as a conversion factor as well. And that, for instance, the number of atoms that are present in 2 moles of aluminum is, the question is asking how many atoms are present in 2 moles of aluminum. So when we say 2 moles of aluminum, the conversion factor to go between moles and number of atoms is 1 mole of aluminum is 6.02 times 10 raised to power 23 aluminum atoms. So this is our conversion factor. What is given to us? The starting unit we have is 2.0 moles. We are going from moles to number of atoms, and the conversion factor to go between that is this. So we start with what's given, which is 2.0 moles of aluminum. Now to cancel moles of aluminum, I will divide by moles of aluminum. This is just like dimensional analysis. The other side of conversion factor is atoms of aluminum, so we'll write aluminum atoms and now plug in the numbers. Mole was 1, atom is 6.02 times 10 raised to power 23. Moles and moles got cancelled. The final answer is in number of atoms of aluminum. So now if you plug in this value into your calculator, that would give you 12.02 times 10 raised to power 23 aluminum atoms, which can also be written as, I need to shift this decimal by 1 place, so that would make it 1.202 times 10 raised to power 24 aluminum atoms. And since this initial number is 2 sig figs, my final answer should be 2 sig figs of 1 and 2, which means 1.2 times 10 raised to power 24 aluminum atoms. So that would be our final answer for this question. Okay, the other question, the number of moles, the other type of question you can expect is the number of moles of sulfur in these many atoms of sulfur is. Question, what is given to us? The question is giving us number of atoms of sulfur and it's asking how many moles is that. So what's given to us is atoms. The question is asking to go from atoms to moles. Do we know a conversion factor that relate moles and atoms? 1 mole of anything, in this case it is sulfur, is 6.02 times 10 raised to power 23 atoms of sulfur. So we'll use this conversion factor. How many atoms are given to us in question? Always write what's given to you first, which is 1.8 times 10 raised to power 23 atoms of sulfur. Now to cancel the atoms, I'll divide by atoms of sulfur, multiply by moles of sulfur. 1 mole of sulfur is 6.02 times 10 raised to power 23 atoms. Atom got cancelled. Our final answer is in moles of sulfur. If you plug this into your calculator, it would give you 3.0 moles of sulfur. So our final answer is number B. Moving on, we'll continue with the concept of moles. Just how in previous topics we saw that moles can be written as 1 mole of a substance. 1 mole of sulfur or copper or aluminum is equal to 6.02 times 10 raised to power 23 atoms. 1 mole can also be used to describe, instead of using one element, we can use the compound. So by compound, we need the chemical formula. So you know, when we say a compound has this chemical formula C9H8O4, that means it consists of 9 atoms of carbon. 1 atom of C9H8O4 consists of 9 atoms of carbon, 8 atoms of hydrogen, and 4 atoms of oxygen, right? This is when we say 1 atom consists of this. 1 molecule, sorry, not atom. 1 molecule, because this is a molecule now. 1 molecule of C9H8O4 consists of these many atoms of carbon, hydrogen, and oxygen. Similarly, we can say that 1 mole of C9H8O4 consists of 9 moles of carbon, 8 moles of hydrogen, and 4 moles of oxygen. So number of atoms in a molecule is same as number of moles of that atom in 1 mole of that molecule. Okay. And what is this? This symbol that you're seeing here is called a compound chemical formula. And each subscript that you see tells us how many number of atoms are present in that particular compound. Okay, so we can use this also as a conversion factor. For instance, 1 mole of C9H8O4 consists of 9 moles of carbon. So we can use this as a conversion factor. 1 mole of C9H8O4 is 9 moles of carbon. Okay, so this is your conversion factor if you want to figure out how many moles of any element are present in this molecule. For instance, a question like this: how many atoms of oxygen are present in 0.15 mole of aspirin? The question is asking, what's given to us is moles of aspirin. The question is asking how many atoms of oxygen are present in there. What would be first conversion factor that we see? First, we'll go from 1 mole of aspirin consists of 4 moles of oxygen. This is our first conversion factor, which will help us to convert from, we cannot directly go from moles to atoms. We will convert moles of aspirin to moles of oxygen first, and then once we know moles of oxygen, we can go from moles of oxygen to atoms of oxygen, because we know that 1 mole of oxygen consists of 1 mole of, number of atoms is 6.02. 6.02 times 10 raised to power 23 atoms of oxygen. So we'll start with what's given, which is 0.150 moles of aspirin. To cancel moles, I divide by mole of aspirin and multiply by mole of oxygen. 1 mole of aspirin is 4 mole of oxygen, like we see here. Now my answer is in moles of oxygen. So I have reached this spot right here. Now we go from moles of oxygen to atoms. To cancel mole, I divide by moles of oxygen, multiply by atoms of oxygen. 1 mole of oxygen has 6.02 times 10 raised to power 23 atoms. Moles and mole was cancelled. Your final answer is in number of atoms of oxygen. Plug this into your calculator. It would give you 3.612 times 10 raised to power 23 atoms of oxygen. And how many sig figs are we looking for? The only relevant sig fig here is coming from 0.150. This is an exact number. This is also exact, so we don't care about sig figs. We'll go from here. This is 3 sig figs, so we want final answer to have 1, 2, 3 sig figs, which is 3.612 times 10 raised to power 23 atoms of oxygen. Okay, moving on, next concept we'll talk about is molar mass. What is molar mass of an element? If you guys remember, we talked about this in the chapter of atoms and elements. In periodic table, you will see with each element, one number is written on top, which is called the atomic number. This tells you how many number of atoms are present in something. Oh, protons are present in an atom. Whereas the number at the bottom tells you what is the mass of atom. So, or the mass of the element. So this basically means when we say, based on this number, we can say that 1 mole of sodium will weigh 22.99 grams of sodium. Okay, so by looking at this, you can say that what is the weight of 1 mole of a substance, 1 mole of an element, but just by looking at periodic table. So from periodic table, you can say that 1 mole of sodium will weigh 22.99 grams. Okay, and this is now a new conversion factor that will help you to go between moles to grams. And the number that you see on the bottom is referred to as, since this is mass of 1 mole of a substance, it is also called as the molar mass of that particular element. Molar mass means mass of 1 mole of that element in grams. So molar mass of an element is the mass of 1 mole of a element, and this is basically used as a conversion factor. Like if you write it in this form, you can use it as a conversion factor. Okay, for instance, if you look at periodic table, you look at the number in the bottom, it would tell you that 1 mole of carbon weighs 12.01 grams. 1 mole of silver weighs 107.9 grams. 1 mole of sulfur weighs 32.07 grams. Okay, so each element you just have to look at the periodic table. So molar mass is the mass in grams of 1 mole of a substance. This is when we are talking about element. For instance, when we talk about moles, if I say a substance like hydrogen, if you look in the periodic table, 1 mole of that would weigh 1.008 grams. And another concept that we know now is that 1 mole of any element will consist of Avogadro number of atoms. So now you can relate the number of atoms to grams. Okay. For instance, 1 mole of calcium will always consist of 6.022 times 10 raised to power 23 atom, and that would weigh around 40.08 grams. So what is the weight of 1 atom of calcium? 1 atom of calcium would essentially weigh 40.08 grams over 6.022 times 10 raised to power 23. So this would be grams per atom. So meaning one weight of one atom in grams. Alright, so that is how you can relate molar mass to number of atoms, or molar mass to number of moles of a substance or an element. For instance, let's try this question. Calculate the moles of sulfur in 57.8 grams of sulfur. So here the question is asking, what's given to us is grams of sulfur, and it's asking what is the moles of sulfur. So we need to basically go from what's given to us as gram, which is 57.8 grams, and what do we need to find is moles of sulfur. So what is our solution map? We need to go from sulfur grams to moles. Do we have a conversion factor that directly relates grams and moles of a substance? Yes. 1 mole of a substance is always its molar mass, which you can get from periodic table. So if you look at your periodic table, 1 mole of sulfur will weigh around 32.01 grams of sulfur. Okay, so this is our conversion factor that will help us convert between these two units. So we start with what's given to us, which is 57.8 grams of sulfur. Now we want to cancel these grams of sulfur, so we'll divide by grams of sulfur. What's the other conversion unit? It's moles of sulfur. So 1 mole of sulfur is 32.01 grams. Grams and grams got cancelled. Your final answer is in moles. If you plug this into your calculator, that would give you 1.80 moles of sulfur. Again, the question gives us how many sig figs right here? 1, 2, 3. So this is 3 sig figs, and we want final answer to be 3 sig figs as well. Okay, moving on, what else? What other question could you look like from the same concept? Something like this. How many copper atoms are in a penny weighing 3.180 grams? So what is the question asking? The question is asking what's given to us. Let's figure that out first. The question is given us that we have 3.10 grams of copper, and it's asking to go from grams of copper to number of atoms of copper. Do we have a direct relationship? So basically we have to go from grams of copper, let's make our solution map, to number of atoms of copper. Do we have a direct conversion factor that relates grams to number of atoms? No. We have a conversion factor that's in the middle, which will help us go from grams of copper to moles of copper. And then from moles of copper, we can go to atoms of copper. So that would be our scheme in this case. So how can we go from grams to moles? We know that 1 mole of copper, if you look at your periodic table, is equal to 63.55 grams of copper. So that is our conversion factor. Where did I get this number from? 63.55, again from periodic table. And now we need to go from moles to atoms. So we know that 1 mole of anything, which in this case is copper, is 6.02 times 10 raised to power 23 atoms. So you can basically use this conversion factor to go from one to the other. Let's start with what's given, which is 3.10 grams of copper. To cancel grams, I divide by grams, multiply by mole of copper. How many moles? 1 mole is 63.55 grams. Grams and grams got cancelled. My final answer here is in moles of copper. So I've reached this step now. Now I need to go from moles of copper to atoms of copper. To do that, I use this conversion factor. So to cancel moles, I divide by moles of copper and multiply by number of atoms of copper. Moles is 1, atoms is 6.02 times 10 raised to power 23. I'm just plugging in the numbers that you see in front of these units. Now moles of copper and moles are cancelled. Our final answer is in number of atoms of copper. If you plug this into your calculator, it will give you 2.94 times 10 raised to power for copper atoms. 10 raised to power 22 atoms of copper. And what number of sig figs we are looking for here is 3. What's given to us in question, and our final answer is also in 3 sig figs. So that would be our final answer for this question. Basically, you should know these conversion factors, that 1 mole of any substance is going to be equal to molar mass of that substance. And we know that 1 mole of a substance consists of 6.02 times 10 raised to power 23 atoms or molecules or ions or particles. Okay, so these are the two conversion factors that relates moles to number of atoms or molecules and moles to molar mass in grams. Okay. The solutions provided to you in this slide as well. Okay, next we will come to molar mass of compounds. Just how we saw right now, we were working with elements. 1 mole of an element is molar mass of an element from periodic table. Similarly, this concept of moles and molar mass can be applied to compounds. What does that mean? When we talk about compounds, we can calculate the molar mass of a compound as well. For instance, if I say 1 mole of hydrogen, water, which is also like hydrogen hydroxide if you want to call it that, but basically if we say 1 mole of water will consist of what? We know from the subscript it consists of 2 moles of hydrogen and 1 mole of oxygen. So what is the mass of 1 mole of water? That would be mass of 2 moles of hydrogen plus 1 mole of oxygen, and that mass is called the molar mass of water. So basically 1 mole of water would weigh how much? It would weigh equal to the molar mass of water in grams. And how can we find molar mass? Basically each water consists of 2 atoms of hydrogen, so it would be, and each atom from periodic table weighs 1.01 grams. So 2 atoms will weigh twice of that, so 2 times 1.01 plus we have 1 atom of oxygen, so it will be 1 times 1 atom from periodic table is 16.00 grams of oxygen. If you sum this up, if you add it all together, that would give you 18.02 grams of H2O. So we have new conversion factor for every compound. We can say that 1 mole of that compound is equal to molar mass of that compound. So 1 mole of water is 18.02 grams of water. So there's your new conversion factor now. You can do this for any compound. As long as you can calculate the molar mass of that compound, you can go from moles of that compound to grams by using this conversion factor. And how do we find weight of that? You use the numbers from periodic table and the subscripts in the chemical formula. Okay. If we were to do this question, calculate the molar mass of lithium carbonate. Lithium carbonate is Li2CO3. So how do we find the molar mass of that? What does lithium carbonate consist of? It basically consists of 2 atoms of lithium and 1 atom of carbon and 3 atoms of oxygen, or 2 moles of lithium, 1 mole of carbon, or 3 moles of oxygen. So if we can find the mass of each one of these, we add it up together and that would give us the molar mass of lithium carbonate. So what is the mass of 1 atom of lithium? You will look for your periodic table right here, this number. Always go for 2 sig figs. Okay, so 2 atoms of lithium would weigh 2 times 6.94 grams of lithium. Next we have 1 atom of carbon. Carbon is right here. You can see the number is 1 atom of carbon weighs 12.01 grams. We'll add that up. And lastly we have 3 atoms of oxygen. One atom weighs around 16.00. If you round it up to like 2 decimal places, always round up the number to 2 decimal places from your periodic table. And we have 3 atoms, so 3 times 16.00 grams of oxygen. You add it all together, and that would give you the final molar mass of lithium chloride. Now remember, when you're plugging all of this into calculator, just make sure you include the parentheses as well. If you do 2 times this, put a parenthesis and then calculate. That would give you a final mass of 79 point something that you saw on that particular slide. Okay. Next example you see right here. What is the molar mass of CH4? Methane. Again, this consists of one atom of carbon. So it would be a mass of carbon would be essentially 1 times 12.01 grams from periodic table. And it consists of hydrogen. How many? 4. So 4 would weigh 4 times 1.01 grams of hydrogen. You add this together and this would give you molar mass of 16.05 grams of CH4. So that is the molar mass of CH4, meaning we can use this conversion factor. 1 mole of CH4 is equal to 16.05 grams of CH4. Now you can use this conversion factor as needed. This is a conversion factor to go between moles to grams of a compound. Again, between moles and grams, it's always 1 mole of any substance is equal to molar mass of that substance in grams. This could be a compound, an element, or an atom. What kind of questions you could see? Something like this. A box of table salt, NaCl, is table salt, contains 737 grams of NaCl. How many moles of NaCl are in the box? So what is given to us? We are given to us grams of NaCl. The question is asking to go from grams to moles. So what's given to us? Let's make our map. Grams of NaCl. We need to go from grams of NaCl to moles of NaCl. What is the relationship that relates moles to grams? It is molar mass. So let's find molar mass of NaCl first. NaCl consists of one atom of Na. So Na would weigh, one atom of Na from periodic table is 22.9 grams. And one atom of chlorine from periodic table is 35.45 grams. Now if you add this up together, that would give you 1 molecule of NaCl. So basically 1 mole of NaCl based on this would weigh around 58.44 grams of NaCl. So that is our molar mass of NaCl. So what is our conversion factor? Our conversion factor is essentially 1 mole of NaCl is 58.44 grams of NaCl. So from here we can go between grams and moles. So we start with what's given, which is grams, which is 737 grams of NaCl. To cancel the grams, I divide by grams of NaCl and multiply by moles of NaCl. How many moles? 1 mole. How many grams? 58.44 grams. So grams and grams got cancelled. Our final answer is in moles, which will give you, if you plug this into your calculator, 737 divided by 58.44, that would give you around 12.61 moles of NaCl. How many sig figs are we looking for? 1, 2, 3. So our final answer would be 12.6 moles of NaCl with 3 sig figs. Okay. The next question says calculate the number of grams in 0.5 moles of NaCl. So now what's given to us is moles, and the question is asking us to go from moles to grams. Again, what is the conversion factor between moles and grams? 1 mole of anything, in this case NaCl, will weigh its molar mass. We just calculated that was 58.44 grams of NaCl. Now you start with what's given, which is moles. So it is 0.500 moles. I want to cancel the moles, so I divide by moles of NaCl and multiply by the other side, which is grams of NaCl. Plug in the number. Mole is 1, grams is 58.44 grams. Moles and moles got cancelled. Our answer is in grams of NaCl. So if you basically now just plug these numbers into calculator, 58.44 times 0.5 will give you 29.22 grams of NaCl. How many sig figs are we looking for? The question has 1, 2, 3 sig figs. So we want our final answer to have 3 sig figs. So our final answer would be 29.2 grams of NaCl. So that is how you can go between moles and grams of an element or a substance. Similarly, you can introduce atoms here, and now you know the conversion factor between moles and atoms as well. So if needed, you can use that conversion factor as well. Okay, so here's like one kind of solution map that is given to you. If grams of an element are given to you, you can go from grams to moles by using molar mass, and from moles you can go to number of atoms by using Avogadro's number. Similarly, if a compound is given to you, grams are given, you can go from grams to moles by using molar mass, and from moles to number of molecules by using Avogadro's number. You could also do reverse. If number of molecules is given to you, we can convert that into moles by using Avogadro number, and then from moles we can go to molar mass, grams by using molar mass. Only important thing is, remember, the midpoint will always be moles. You have to figure out moles in the to figure out any of the other components. Okay, so in chemistry, what's the most important thing or the most important unit of an amount of a substance is moles.